So we start here with the common information model. You can see that the information model for the Festo MPS 403-1 is a part of a library of lots of different information models. What's important about this one is that we've agreed to interoperate on this information interface. The type definition is made up of subtypes. We might call those submodel templates. At SESME, we call them profiles. And profiles can be made up of other profiles. Exactly what word you use to describe these doesn't matter. What matters is that we have a common information model so that as an application developer, I know what to expect when I connect to a data source. So this is the type definition in the abstract. I can also see a specific instance of the equipment actually connected to a data source. So here is the MPS 403-1 sitting in Germany that I'm connected to. And if I want to, I can trend the data live from that machine as it's coming in across the internet through the Azure Data Center. What we wanted to do for this demonstration is take this MPS 403-1, which is a training unit made up of multiple stages and phases, and imagine what it might look like if we standardize on this information model across a plant and across an enterprise. So we've extracted the different stages and phases that are a part of this training module, and we've attached them to virtual assets in this demonstrator. One of those assets is a batch tank, and you can see that the batch tank is made up of submodel templates or profile implementations that have some of the data that we're getting from our training asset. The mixer motor is a component of the batch tank. The mixer motor itself has a profile that allows us to understand the data coming from the mixer motor. The batch tank has a profile that is the carbon module. The carbon module helps us to understand the carbon output of the batch tank. But the motor itself also implements the carbon module. So if I look at its attributes, I can see that CO2 emissions are a useful data point. And I can also see that the motor can't tell me its CO2 emissions by itself. It can tell me its energy use, but I have to combine that with the energy source to really understand what my carbon footprint might look like for that motor. Then when I drill into the motor, I can see meaningful carbon data as part of the carbon interface for this part of a larger asset, as well as seeing the carbon output of the larger asset. And I can trend this as well if I'd like and get as much detail on the component data as I want. The component being part of a larger asset. The asset is part of a larger system. So the motor is part of the batch tank. The batch tank is part of this plant that I have in California. And each asset in the plant has standardized on a common information model for CO2 reporting. That allows me to look across my facility and get a rolled up KPI of the CO2 equivalent output, and even identify where my problem assets are and the components of that asset that I might want to drill into. This is the sweetener batch tank. This is its relationship with the other assets. And this is my indicator that I'm out of the target range for CO2 output for this asset. I can trend that data as well and dig in deeper. I might also produce reports. As well as looking at live data, I may want to standardize on reporting across my sites. So I can use this same tool to produce those reports that allow me to compare across assets, or more importantly, across sites. So if we zoom out one more level, I can see that the California plant is part of an enterprise that has plants in different locations around the world, all of which have standardized on this common information model for CO2 reporting. And that allows me to compare my California plant's output with my German plant or my UK plant. And from there, drill into the details on those facilities as well. The common information model allows me to interchange data between sites, but also understand information as compared between sites, to interoperate on a common set of KPIs that can help me do better, not just at the component level or the asset level or the site level, but across my enterprise.